From e-commerce, new developments and products to gadgets and games, and for everyone interested in the internet and new media. Now on BBC News, all the tech to revolutionise business and personal life. It's Click.
This week, is it a boat or is it a plane? I'm on board the ferry that can fly.
Why has nobody made an electric hydrofoil flying ferry before?
I think the main reason is that it's freaking hard.
We're in India where solar dryers are battling food waste.
And an eye in the sky on energy use. Nice outfit, by the way.
Thanks. I've been taking the temperature with the world's thermometer to assess the climate impact of all our actions.
Stockholm, capital of Sweden and a city of islands. 14 of them to be precise, which makes water transport a big thing around these parts. So today, I've decided to take the ferry.
But this is no ordinary ferry, because this ferry can fly.
This is the Candela P12, the prototype of a ferry which should go into service in July 2024. And at its cruising speed of 25 knots, narrow wings called hydrofoils provide huge amounts of lift. In the same way that aircraft wings can get a plane off the ground, these wings can raise the whole hull above the surface.
I've started to notice more and more boats and even windsurfs and kite surfs having these foils underneath the board so the entire thing can lift out of the water.
And because hardly any of the boat is having to push through the water, it doesn't need as powerful a motor. And that means there's something else that's very special about this craft.
It's electric.
These small propellers are all that are needed to get the ferry up to speed, and its onboard batteries give it a range of 50 nautical miles, all of which promises to make waterborne transport a whole lot cleaner and a whole lot greener.
Normal boats consume an awful lot of fuel, and they are extremely inefficient compared to land-based transport.
And this is because the boat is trying to push its way through the water. There's a lot of resistance, isn't there?
There's a lot of friction in the water. You can use batteries on ferries if they run very slowly. But whenever you want to go a bit faster, a bit longer distances, then the whole thing collapses. Because you could, of course, put in more batteries, but at the end you put in so much batteries that the boat will sink. So you have sort of a physical limit here that you can't get around.
Yeah.
Gustav says that 1 hour of charging will allow this ferry to run for 3 hours, meaning it could service commuters during the morning rush on one charge and be ready for the afternoon peak after being recharged at lunchtime. There's another advantage to being almost entirely out of the water too. It doesn't bounce about on the waves.
And I've got to say, it is pretty steady. I mean, I can't quite tell that I'm out of the water, but I can tell that I'm not feeling all the waves that I can see around. And actually, our camera boat is using the same hydrofoil technology, so you can see that it's also out of the water, which means that they can get some pretty rock steady shots of us too. I mean, look at Martin, he's having the time of his life out there.
But whereas the C8 speedboat is built for pleasure, leisure and basically showing off, the P12 ferry is being pitched as a way to make waterborne public transport competitive again, both in fuel costs and in environmental costs too. Because as well as not feeling the waves, it doesn't make them either. And that's good for everything that lives here.
Traditional ferries creates big wakes And when it dries in our sensitive archipelago, it's a really sensitive ecological system with marine life, and we have the birds and the fishes. It causes erosion from the shorelines. And that's a really big challenge for us. We need to reduce the wakes to be able to drive more in a sustainable way in our sensitive environment.
The principle of hydrofoiling is not that new, but it's only recently become possible to do in this way. The first reason is that we now have materials that are up to the job.
You need these very thin blades that should be super strong but very thin to not create too much drag. And typically nowadays you use carbon fiber for that, which is a perfect material. And you can build them then in fairly small volumes. Otherwise you would have to rely on steel, it becomes heavy, costly to manufacture and so forth.
And the second reason is all the high-end computation that's going on below deck.
Okay, here's the science bit. When you raise a boat almost entirely out of the water, it becomes unstable. And that's because you've got all the weight up here above the wings that it's balancing on in the water. It's a bit like trying to balance a pencil on your finger. In order to keep it upright, you have to do a lot of that. And that's what this boat is having to do. It's having to adjust its position hundreds of times a second to keep it perfectly balanced. You couldn't do that manually, so this thing is covered in sensors that monitor exactly what its orientation is, and then the computers are doing that compensation, and they do that by adjusting the angle of the wings in the water, again hundreds of times a second, to keep it perfectly balanced.
It's the same reason why drones are able to stay stable in the air. And in fact, on these early test flights, Christian here is able to tweak and experiment with the boat's behaviour by changing the settings live on his laptop.
We're turning. One of the things that you can do when you're precisely controlling the orientation of the boat at all times is you can artificially bank like this when you're turning, which is more comfortable for the passengers. Because if the boat was to remain level, everyone would be pushed to one side. So this banking is artificial.
There is a limit to the size of the swell this type of craft could cope with, but on inland waterways, this technology may very well soon be making waves by not making waves. Although, like a lot of modern life, the smooth ride will depend on the computers and sensors doing their jobs at all times, which is no mean feat.
Why has nobody made an electric hydrofoil flying ferry before?
I think the main reason is that it's freaking hard.
Over 70 countries have commitments to net zero targets. Some are enshrined in law, others are goals laid out in policy. Large companies have also made net zero pledges, but how do we know that they're being met? Well, there's one company that might have the answer. Satellites have been capturing images from space for decades. This is a radar one here. You've also got optical images like these. Any cloud cover around and you won't see what's going on beneath, and you need daylight for most of these. But Satellite View has a different plan. For them, it's all about thermal imaging.
Engines full power. And liftoff of Transporter 8. Go Falcon, go Transporter.
Its first satellite, HotSat-1, was launched in June on a SpaceX rocket flying out of California. It started sending back high-resolution images to Earth, its thermal sensors enabling it to trace hot and cold features down to 3.5-metre accuracy.
Under that circle, there's a lot more than 4 kilometres.
Yeah. It's the culmination of years of work.
We have Satellite View, the world's thermometer. Literally, these are the raw images. We think we can make them a lot better. But here, the first image we ever took was of Rome. And you can see that the hot areas are in the brighter colours and the blue areas are the cooler areas of the city. This one's taken at night, And so what you can see right here is the Vatican is very, very hot. So
Okay.
that building this summer, where you remember there were big heat waves,
Yeah.
absorbed a lot of energy, and at night it's radiating it.
HotSat-1's heat maps, which are still images and short videos, could have wide application, but are particularly useful in climate-related matters.
We think every city will want this. There's a new city managers called chief heat officers, and there's 7 of them appointed around the world. And one is in Athens, for example, and they are wanting this data so they can go and help keep the city cooler, to keep the stress on people less and save energy.
But the bigger picture is to help monitor how companies are meeting their net zero commitments.
You can look at oil storage, for example, and see how much fossil fuels are being burnt and how much are being pumped. So when people are declaring net zero or they're reducing their oil consumption, we can come and verify that that's actually occurring.
60 organisations are currently playing around with these early heat map images to see if they can be used to improve their existing climate models. HotSat-1 was assembled by Surrey Satellite Technology in Guildford.
You get one shot at launching something like this, so how stressful is the process?
Yes, pretty stressful. I think it is a high intensity business, and especially projects like this that are very short schedule, but it is very exciting when it does launch.
7 more satellites will be joining HotSat-1 over the next few months. The aim is to increase the amount of data that's being collected, which is identifying temperature profiles of individual buildings, offices and factories.
If we're striving to help the planet, if we're striving to get to net zero, you need this transparency of information, and we've done it.